Hi everyone. Today we are going to start solving exponential and logarithmic functions. Remember, up to this point, we can change the way it looks. We learned change the way it looks, meaning I can move from exponential to logarithmic and vice versa. We also know how to, once we have it as a logarithm, how to put that into the calculator. That is what we did in our last video. So now we're going to solve the exponential functions algebraically, and we're going to give the answers in exact form and decimal form. So the problem is when we get to something like this, 2 to the x equals 50. When x is in the exponent, and that's going to be the case with all of these, we have to change the way this looks. We have to rewrite it as an exponential, from exponential to logarithmic form. And remember, yes, the last video, you've got this little key of how to convert from one form to the other. So if you feel uncomfortable doing that, please ask. I can provide supplemental resources, maybe do the homework for that section before you get to this one, because you do need to feel comfortable with that. So I'm going to change this to logarithmic form. So logarithmic form from here is log base 2 of 50 equals x. So do you see how changing it from exponential form to logarithmic form already put it to where x equals this thing? And I'm done. I've solved for x. This is what we call the exact form. This is as exact as it gets. We don't have to like go to certain decimal places or anything like that. This is as exact as it gets. However, if you want to put it in your calculator, you can go again. I'm going to do this one time in this video to remind you. Math and then A, and it's log base 2 of 50, and that gives me 5. I'll go to 2 decimal places. 5.64. And again, that is an approximation because we had to round. Okay, so that's great. If you can, try to get it to where the exponential part is by itself. So what I mean by that is, in this one, we need to move the 70 first. So I'm going to move the 70 by subtracting 70, and I'll get 500. And that is 3. That should be 3x. I apologize, not 30. And then I need to get rid of this 5. 5 times 6 to the 3x, I can divide by 5. If I divide by 5, 500 divided by 5 is 100. And then I can do what I did earlier, basically. Once it looks like this, once you've simplified it a little bit and cleaned it up, then you can move from exponential to logarithmic form. Again, why are we doing this? Because the x is an exponent. So it's going to be log of 6, log base 6 of 100 equals 3x. The x is not solved yet. I still need to divide by 3. So log base 6 of 100 divided by 3 is my exact answer. If I put this in the calculator, again, feel free to pause and do this. Make sure you are getting these answers. I'm going to go to 3 decimal places this time. Again, on a test, I will tell you what to go to. So if you're unsure, that information will be explicitly given to you. So those are my answers. This is the exact answer, and this is an approximated answer. Okay, on number 3, same thing. We need to get rid of the 4. E is just a base. E is, remember, 2.7, blah, 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 blah. So it's just a number. So just like we got 6 by itself, we need to get E by itself. I'm going to divide by 4. So e to the 3x, 248 divided by 4 is 62. Okay. When you convert this from logarithmic to exponential form, if you want, you can make it log base e of 62 equals 3 to the x. Okay, really quick. Log base e, so I went from this form to this form, and the e is the base. Oh, I'm so sorry. When I went from this form to this form, e was the base. Remember from our previous video, log base e is the same thing as ln. So I can rewrite that as ln of 62 equals 3x. Let's see if I can get that to, come on. There we go. I still haven't solved this. I need to divide by the 3. So ln of 62 divided by 3 is equal to my x. Or if I put that into my calculator, again, I have an ln button. I can put natural log of 62 divided by 3, and I get approximately 1.38. Okay. Sorry, this is so blurry. All right. Keep going. Solve the following logarithmic functions algebraically. Give the exact decimal approximation for each answer. Okay, so first we had exponential and we had to use logarithms to solve. Now we have logarithmic functions, and perhaps there is a way that I can rewrite this from logarithmic to exponential form, and so I'm going to do that. I can rewrite this as 2 to the negative 5 equals x. Yes, you can put exponents in your calculator. 2 to the negative 5 is the same thing as 1 over 2 to the 5th, by the way. So when you get a decimal, that's y. X is the same thing as 1 over 32, or that as a decimal is, I'll go to 2 decimal places, 0.03. Okay, so we can do the same thing. We can move from logarithmic to exponential form and vice versa to help us solve these equations and these functions. But similarly to the above, I want to make sure that I have just log on this side. So what I mean by that is I want to get rid of this 5. And I'm going to divide by 5, and I get a weird number, and that's okay. So log base 6 of 2x is equal to 16 divided by 5 is 3.2. It's okay to not get whole numbers. It's all good. But the x is still kind of being stuck with the log. So I need to rewrite this in a way that I can solve it. So I'm going to go from logarithmic to exponential form. 6 to the 3.2 equals 2x. Then again, I can divide by 2. So 6 to the 3.2 divided by 2 is technically the most exact way to write this answer. But if you want to put it in your calculator, I get 154 I'll go to 3 decimal places, 4.545. If you want to try the next one, please feel free to do so. I'm going to go ahead and do it. So if you want to try it on your own, go ahead and pause the video. So I've got natural log of x. I need to move the 5 and the 2. I'm going to move this 5 first. When I move the 5 to the other side, I'm going to subtract it and get 14. Then I'm going to divide this 2. 14 divided by 2 is 7. Here I am. All right. we're a little stuck, right? The x is stuck and I have ln and I can't move it to exponential form. Or can I? Remember, natural log is the same thing as log base e. So I can change it from natural log to log base e and then convert this from logarithmic to exponential form, which would be e to the 7 equals x. That is the most exact answer. You can also put e to the 7 in your calculator. Remember, e is the one with natural log, so I'm going to put second ln to get e to the power of 7 to get an approximated answer. So that approximated answer is 1096. I'm going to go to 2 decimal places, 6.3. Sorry about that. Keep forgetting to zoom out for that last little bit. All right, and then last 3 that we're going to do today, we are going to solve using exponential or logarithmic function. We're going to solve these exponential or logarithmic functions, and we're going to try to figure out how we can do this. Like, what decisions do I need to make? What do I need to change? And I just want to recap really quickly. The reason we have to do this is, for a lack of better word, the x is stuck. Either stuck in an exponent and we need to rewrite it, or stuck inside a logarithm and we need to rewrite it in a way that we can solve for x. And so we're not changing the values of these, we're just changing the way they look. If you want to try these for yourself, please feel free and go ahead and pause this and try them. If not, I will do all 3 of them to make sure you still feel good about it. So again, what we want to do is we're going to solve for x, but there's lots of stuff happening, and I want to get that 36 to the other side, and eventually this 6 too. So I'm going to add 36, and if I add 36 to 18, I will get 54. Then I want to get rid of the 6. If I divide by 6, 54 divided by 6 is going to be 9. So e to the x equals 9. I haven't even solved this yet. My x is still in the exponent, but I've cleaned it up to make it to where when I convert to logarithmic form, it's just going to be a lot simpler and less numbers to work with. So I'm going to change from exponential to logarithmic form, and this as logarithmic form would be log base e of 9 equals x. Again, log base e is the same thing as natural log of 9. That is the most exact form. If you want an approximated form and put it in your calculator, you'll get that is a really bad approximation symbol. You get 2.1972. I'll go to 4 decimal places. All right, I'm going to keep going. Please pause the video if you needed a little bit to think about that. All right, I need to solve for x, and it's kind of stuck. I'm going to get rid of this 5 and this 2. I'm going to add the 5 first. So 2 log x equals 6. Then I'm going to divide 2. Log x equals 6 divided by 2 is 3. I have one problem. If I want to convert from logarithmic to exponential form because the x is stuck and I want to get it unstuck, I don't have a base. I never had a base. Technically, I do, but it doesn't show one. If it doesn't show a base, you can assume it's 10. Again, this is called the common log. If it doesn't show it, you can assume it's 10. If you forget that, in your calculator, next to the log button is 10 to the x. So if you forget, 10 is right next to log. Maybe that will help you remember. All right, so I'm going to convert this from logarithmic form to exponential form. This as exponential form is 10 cubed equals x. And if I put this in my calculator, I get 1,000. I don't have to approximate. I only have the exact answer. All right, let's do one more. again, I want to get all this stuff away from 5 to the x plus 1. So I'm going to move the 6. If I move the 6 to the other side, I will be subtracting it. So I'll get 3, 9, 6, 0. And then I want to get rid of this 8. To get rid of this 8, I'm going to divide. So if I divide both sides by 8, 3,960 divided by 8 is 495. Okay. At this point, I, again, can convert from exponential to logarithmic form because that x is stuck in the exponent. This is logarithmic form would be log base 5 of 495 equals x plus 1. Wrong one. I still haven't solved for x. It's x plus 1. I need to get this 1 to the other side. To get the 1 to the other side, I'm going to subtract it. And I'm going to subtract the x after I've done all of this. There we go. I'm going to subtract the 1 after I've already done all of this logarithmic stuff. So the minus 1 is out to the side. It's not like if I subtract 1, this is going to be 494. That's not how it works. You have to keep them separated. So that is the most exact form. If I were to put this in my calculator, I can approximate it. And x would be I'll go to 3 decimal places, 2.855. All right. Now, up to this point, you have what you need to do homework 8. If you have any questions, please let me know.